Gaze up at the night sky. It's a breathtaking tapestry of twinkling stars and distant planets. What you might not realize is that everything out there is in constant motion. Stars spin on their axes, planets dance around stars, and entire galaxies whirl through the cosmos. It's a grand cosmic ballet, all driven by the laws of physics. Rotation is a fundamental property of our universe. It's everywhere we look, from the tiniest particles to the largest celestial bodies. But why? Why is everything spinning? The answer lies in the majestic process of star and planet formation. It all begins with a vast cloud of gas and dust, a nebula, the cradle of stars. These nebulae are dynamic and chaotic realms. They're in perpetual motion, influenced by gravity and other forces, and it's from these swirling clouds that stars and planets are born. Picture a vast, enigmatic cloud of gas and dust, light years across, drifting through the cosmos. These clouds, known as nebulae, are the mysterious birthplaces of stars and planets, the cradles of creation in the universe. This is a nebula, a stellar nursery where stars ignite and planetary systems take shape. Within these immense clouds, the seeds of future solar systems are sown, waiting for the right conditions to spark life. These clouds are not uniform, they have regions of slightly higher density. These denser regions are crucial as they are the starting points for the formation of stars and planets. Gravity, the unseen architect of the universe, pulls the gas and dust in these denser regions towards each other. This gravitational pull is the invisible hand that shapes the cosmos, drawing material together to form new celestial bodies. As more material clumps together, the gravitational pull strengthens. This process of accumulation continues, with gravity acting as a cosmic magnet, attracting more and more gas and dust. The cloud begins to collapse in on itself, slowly at first, then faster and faster. This collapse is a critical phase in the birth of a star. As the material is drawn inward, the pressure and temperature at the core increase. This collapse is not a uniform implosion. Different parts of the cloud collapse at different rates, creating a complex and dynamic environment. The cloud, like most things in the universe, has some amount of spin, a remnant of its own formation or interactions with nearby celestial objects. This spin plays a crucial role in the formation of the star and its surrounding planetary system. As the cloud collapses, this spin amplifies, much like a figure skater pulling their arms in during a spin. The conservation of angular momentum causes the cloud to spin faster and faster as it contracts. This spinning, collapsing cloud eventually becomes so dense and hot that nuclear fusion ignites in its core. A star is born. The intense heat and pressure at the core cause hydrogen atoms to fuse into helium, releasing vast amounts of energy. But the story doesn't end there. The birth of a star is just the beginning of a new chapter in the cosmic saga. Around the newborn star, the remaining gas and dust continue to swirl, forming a protoplanetary disk. This disk is the nursery for planets, moons, and other celestial bodies that will orbit the star. Over millions of years, these particles will collide and stick together, gradually building up into larger and larger bodies, eventually forming planets. The process of planet formation is a slow and intricate dance, governed by the same gravitational forces that created the star. As the planets take shape, they clear paths in the disk, creating gaps and rings that we can observe with powerful telescopes. Eventually, a mature solar system emerges, with planets orbiting their star in a delicate balance. Each planet, moon, and asteroid is a testament to the incredible processes that govern the universe, from the smallest particles of dust to the largest stars. And so, from the humble beginnings of a cloud of gas and dust, the universe creates the wonders of stars and planets, each one a unique and awe-inspiring part of the cosmic tapestry. As the nebula collapses and spins ever faster, an awe-inspiring transformation begins to unfold. At the core of this transformation is a captivating law of physics known as the conservation of angular momentum. This law tells us that in a closed system, the total angular momentum remains constant no matter what changes occur within the system. So what does this mean for our collapsing cloud of gas and dust in the vastness of space? To grasp this, imagine a figure skater spinning on an ice rink. When they pull their arms in close to their body, they spin faster and faster. This happens because their angular momentum is conserved, meaning it stays the same even as their body changes position. With their arms closer to their body, their rotational inertia decreases and their spin rate increases to balance this change. The same principle applies to the collapsing nebula in space. As the cloud of gas and dust shrinks, its rotational speed increases to conserve angular momentum, just like the ice skater. This spinning motion is then transferred to the star forming at the center of the nebula and also to the disk of material that surrounds the young star. This is why stars rotate on their axes, and it's also why planets, which form from the material in the disk, also rotate and orbit their stars in the same direction. The conservation of angular momentum ensures that the motion initiated in the nebula is carried through to the formation of stars and planets, creating a mesmerizing and interconnected cosmic dance. This principle doesn't just apply to individual stars and planets, but to entire galaxies and cosmic structures, all bound by the same fundamental laws of physics. As we explore the universe, we see the conservation of angular momentum at work on every scale, from the smallest particles to the largest cosmic formations, shaping the very fabric of our cosmos. Understanding this principle helps us appreciate the intricate and beautiful mechanics of the universe, reminding us of the delicate balance that governs all celestial movements. Our cosmic dance, Earth's daily spin. We live on a mesmerizing spinning planet. Earth completes a breathtaking full rotation on its axis roughly every 24 hours, gifting us with the cycle of day and night. This majestic rotation is a legacy of Earth's birth within the swirling disk of gas and dust that surrounded our young sun billions of years ago. Yet Earth's rotation is not perfectly uniform. It's subtly influenced by the gravitational embrace of the Sun and Moon, the intricate distribution of mass within the Earth, and even the dynamic movement of our atmosphere. These factors cause slight yet fascinating variations in Earth's rotation rate on the order of milliseconds. While these variations may seem minute, they're crucial for scientists exploring Earth's internal structure, ocean currents, and even the long-term stability of our planet's climate. Venus, the enigma of the solar system. While most planets in our solar system spin in harmony with Earth, there's one baffling exception: Venus. Venus rotates at a snail's pace, taking about 243 Earth days to complete just one spin. Even more perplexing, it spins in the opposite direction to nearly all other planets. This retrograde rotation is one of the greatest mysteries of our solar system. Astronomers have put forth several intriguing theories to unravel this enigma. One dramatic possibility is that Venus was struck by a colossal object early in its history, flipping its spin direction. Another theory suggests that Venus's dense atmosphere, some 90 times thicker than Earth's, could have interacted with the planet's gravitational field over eons, gradually reversing its rotation. Whatever the cause, Venus's bizarre rotation is a stark reminder of the solar system's astonishing diversity and complexity. Earth's gentle rotation. Our planet, a magnificent blue marble, spins gracefully in the vast expanse of space. If Earth is spinning so fast, why don't we feel it? It's a question that often puzzles many. Despite the incredible speed at which we are moving, our daily lives seem unaffected. After all, we're hurtling through space at over 1,000 miles per hour. This speed is mind-boggling when you think about it, yet we go about our routines without a second thought. The answer lies in the gentle embrace of inertia. This fundamental principle of physics explains why we don't feel the Earth's rapid rotation. Inertia is the tendency of an object to resist changes in its motion. Imagine a ball rolling on a flat surface. It continues to move smoothly unless acted upon by an external force. Because Earth rotates at a constant speed and we're rotating with it, we don't feel any acceleration or deceleration. This constant motion is seamless and unnoticeable to us. It's like being on a train moving at a constant speed. You only feel the movement when the train accelerates or brakes. As long as the speed is steady, the ride feels smooth. Furthermore, the gentle pull of gravity keeps us firmly planted on the ground. This invisible force pulls us towards the center of the Earth, ensuring we stay grounded. This force is much stronger than the centrifugal force generated by Earth's rotation, which is why we don't fly off into space. The balance between these forces keeps us safe and stable. Our senses are simply not sensitive enough to perceive the constant, smooth rotation of our planet. We are designed to notice changes, not constants. We only notice the effects of Earth's rotation indirectly, through the cycle of day and night and the apparent movement of the sun across the sky. This daily rhythm is a gentle reminder of our planet's perpetual motion, a dance that has been ongoing for billions of years.